I work here at Schultz. Have been for a couple of years, 12 years. We use Elasticsearch for a bunch of different things actually, but I've selected one of our specific use cases today, which I'll be diving into, which is a very exciting one: efficient audit trail data, where efficient is audit trail. That is something that just needs to be there, and it is something we just want to just work, and we want it to not cost us a lot. We want it to just work. Especially since we are a private company making systems for clients, public clients. So cost efficiency, that's something that we care about. I'll just quickly dive into our history with Elastic and using Elastic. I will make it to my machine. We started out using getting experience with Martin. How to fix that? Think you remember that? Well, the thing where it's starts turning off and on. Can you try something? I'm just talking. So we started out back in 2015, and actually just started with the hackathon. A day where developers they could try out something new they want to try out. And at that point, I was a developer myself, and I was part of the hackathon actually. And the thing we wanted to try out back then was we have these application logs from systems that we do mostly with systems. We do some logging in our code, and when there's something wrong, we have a follow-up, and then I can, if there's an error, I can find that in the log, and then it says something went wrong, and I can see, oh, it was something that happened on this other server over here. Oh, wait, it didn't just go over there and find that file over there. So we were logging into files on different servers and different applications. It was just very hard to do any serious logging. So we just wanted to be able to do have our log searchable and have them correlated, so we can actually search across different parts of applications. And this was based on back then when everything Elastic was called Elk Stack, Elastic, Logstacks, and Kibana. We did a little bit of Logstacks, not that much. And that's also where we started doing structured logging. We are primarily using .NET, so we use C#, and there's a logging library called ZeroLog, which is helped us to do structured logging. So you can actually log something that where you can log your own custom attributes, so you can actually build them that. And then over the years, it became widely used. I think most teams started adopting Elastic slowly for, first of all, application logs, just getting those logs we already produce in our system, just get that somewhere in a common place and we can search for them. We built on that to also include the logs from our web servers, yes, Microsoft.net, and also server metrics from what was it called? Called Beats. Wasn't there something before Beats? Is it just Beats? Metric Beats?
I mean, we had Beats.
Yeah, I think it was just Beats. Yeah. So Beats you can install on the servers to connect the metrics, CPU, memory, disk usage, that kind of stuff. And then we, at some point, started adopting using also APM, application performance monitoring, which is more Elasticsearch specific product. And over the course of the year, we started using Kubernetes for some of our applications as well, and we use that as well to grab metrics from Kubernetes as well. So about those use cases we have, first of all, just a short background is that the use cases we have here is from our system that is called Schultz, which is a case management system for the employment sector in Denmark, used by Danish municipalities. And yeah, it's a product we've built over a lot of years, and a bit of metrics. We have around 10,000 users every day, caseworkers across the municipalities that use our system for their various needs. It's a fairly regulated environment. If you're from Denmark, you know that employment is something that is very well regulated from our government. So that is definitely something that is part of our day-to-day work. We, as I said, started Elasticsearch with just the logs use case, put logs into Elasticsearch. And over the years for our product, Schultz, which is the biggest product we have with here in Schultz, we have 4 different cases use cases. We have our application search, which is a tool where users can actually build their own work list. So what do I need to see on my screen when I log into Facet? What is it that I need to do in this system that is basically built on Elasticsearch, where we constantly index data into Elasticsearch live so that it always up to date. So you can answer questions like, what must I book for follow-up meetings this week? This is very much the kind of thing that caseworkers do on a day-to-day basis. They need to know, today I need to get this work done. And they do this by Elasticsearch. Another case we have is change logging. And this here is still from the user's perspective. So I'm working as a caseworker with the citizen, and I don't know why is this case why does it have this start date? That sounds wrong. Maybe go into the change logs, and I can drill down and see where the data why the data changed back that day from that day to day. That that was John who did it. That's also from the user Elasticsearch. Third is observability, which is basically what we started out with, logs, APM, monitoring our infrastructure. And lastly, we also use it for audit trails, which is a legal requirement for our clients, our customers, that they need to keep checks on their own employees, that they are not looking into things that they're not allowed to. Being the employment sector, there's a lot of sensitive information around citizens, so they need to be able to ask their own employers, employees, why did you look at your neighbor last week? That's a bit strange. Could you please explain that to me? And this can be the cause for punishment. That's what they mean. Let me just go through that. So
oh no.
The case I want to dive in today is the one we have around audit trails. Just to say that we have for specifically place, but we have for use cases. We use Elasticsearch for fairly different things. An audit trail, in some ways, the most can't call it right, but it's something that it just needs to be there, right? But it needs to be there. If it's not there, it's a huge problem. When it's there, everyone's happy. So what the audit trail needs to be able to support is to see if to do what's called stick problem. Samples on let me just see what you just started. Let me just see what you just started. They have to do that. So to do that, they need to be able to make searches in this audit trail for who were looking into the system, who was browsing in the system for looking at a search system. You have to be able to say who they looked at, and also when they did that. So was this that happened? Something happened last week. Why was it last week? We did not months ago. How is that relevant to it? And finally, the requirement we also have is that we have to store these data for 180 days, because that is the requirements. That's a reasonable amount to have this data, and then no longer, because otherwise it's still tracking employees at a company, even though it's a public company, municipality, but it's still tracking personal data. So the way because of the way we collect the logs, it actually becomes a huge amount of logs compared to what it is we're doing, right? We have 10,000 daily users. We're not Amazon, right? With millions of users. We just have 10,000 paid workers. But the thing is that we need to be damn sure that we're collecting things properly every time without any hiccups. So this is just a snippet from the user space that the user is seeing, where they can do different kinds of searches. So, I can see it's a bit small, but what I'm just basically, I just pulled out a snippet of code where it's a class, some sharp code, where this log statement is reduced from. So this is happening inside of every single API we're exposing to our user space. We have a web application, which is it's a React-based application, which is like a big browser client, which does API calls, and every single call that a page makes to our server, that is what we logs based on. That also means that if I just click on a citizen or link and I see a page, I might make 30 calls to the backend, because it might collect different pieces of data to be able to show this to the user. That means that we get a lot of data. And to keep it as simple as possible, we just store it forward every single time. So when looking back, when we were choosing this platform, choosing Elasticsearch as a platform for this use case, because we had a very specific decision process on using Elasticsearch for this, because there could be other ways to use to build a auditing system around. Previously, this was a rework of something we had earlier. The earlier solution was based on putting stuff in a SQL database. And when we came around to have, we had a project where we need to modernize this because of other reasons. We were very much aware about how much data we were going to be able to handle. About 100 to 200 entries every second, from 8 in the morning to 16 in the afternoon. we can very much in our system see when case workers come to work, when they go to lunch, when they go. That's very easy to see now. And it's just about 1 to 2 terabytes of data, which is not a lot. It's not massive numbers. This is not crazy scale. And that's kind of my point with taking this use case also, that even though Elasticsearch is very much something that can scale to insane sizes, it's actually also very effective at smaller sizes. And this logic frame case is definitely not our feature. That's the Elasticsearch. That's the big expert, which is also a hugely complex process. But still, we knew very much upfront when we were going to redesign the solution about the performance characteristics of the system, how much load we could expect to be able to put into the system. So we started out looking at different options. Elasticsearch was not our first thing we looked at. The first thing we looked at, of course, was SQL Server, or again, .NET Microsoft House. So we use SQL Server, Microsoft SQL Server as that's the database we have the most competencies in-house. And perhaps I should have written Azure SQL because we moved to Azure now. But still, if we're looking at Azure SQL, which is basically just SQL Server running in Microsoft Azure, it was still a fairly expensive solution compared to our needs. As I said, this is something that we benefit from keeping cost effective. We just need to be able to solve the problem of collecting all these logs, store them somewhere, and when someone needs to search for them, they can get back on those logs with a 5 or 6 options. And SQL Server was fairly expensive. Partly, I believe, because that it's not that easy, and there might be options for we couldn't find something easily to really tier your data, saying this is data that I can accept longer response time. It's fine for me that these logs, there's minutes of delay. That's perfectly fine, and the search is okay. It's slow. It's not that easy to fine tune that on it's very good at giving all the promises that SQL does. Another option we looked at was Azure Storage Account, the table storage option, where you can basically just put things into a very generic table schema, and it is insanely cheap. It's very, very cheap, very cheap, very effective. Generally, Azure Storage Account, there's the same thing with AWS as well. Their storage options is very cost effective, but it's also extremely limited in what it can do. That's also what you pay for the other way, what you have to design around. So it's very different what you could do with searchability. That's basically just a signature of an index on your data. And then if you want to search on more than one parameter attribute, you have to figure out some way to store your data in multiple dimensions or something. So that puts complexity over us that to have to do things for that. And we also have some other technology options we looked at, but not that large. But we ended up with Elasticsearch because we had knowledge prior already with Elasticsearch that it has a very powerful search engine. That is basically what the last part of the name is. And the fact that these data in order trade, that is time series data. That is data that is coming in over time. It's always coming in at the today. Sorry, right now. And that is perfectly suitable with Elasticsearch's ability to do different data tiers. That's really where it works really great together. So from a point of view of the data, what we do is Elasticsearch is very good at sharding data and doing searches across multiple. I've drawn them as databases, just so it's a database, right? But it's not a database. Every single of these databases have that's the index in Elasticsearch. Every single index has a name, which is basically the date of the data which they store data from. And whenever we connect our audit trailing, it basically goes into a index with the name of the current date on it, and then we just we just write it. So we have in our application ourselves. This is very much how Elasticsearch in general worked back in 2015 when we started out, before any fancy things like rollover and lifecycle policies. It was a very common way to do Elastic, that you have to yourself maintain. I want to write things in data indices so that I can, when I don't want to store data any longer, it's very easy for me to say, okay, every data that is older than, in this example, 10 days, that just doesn't exist, because the only thing I need to do is just be the one that's called 2023, 11, 17. That's basically just delete that, and then I've done my retention. I don't need to scan for cleaning up, and I can just delete the one with that. So that is also the scheme we're using for, or the methodology we're using for our audit trail, because that's a very easy way to keep retention at a fixed interval. Even though, as I said, Elasticsearch has done a lot to move over to what's called rollover mechanisms, where Elasticsearch can automatically roll over an index with index when it gets either too large or too old, which is great for logs, where you want to compact things as much as possible into the right size of an index, which apparently is 25 gigabytes per shard. Or 50 shard. The magic numbers. No, there's different sizes that you need to know a bit about with Elasticsearch when to do cutoffs, but that is something that Elasticsearch is doing a lot more, handling a lot more often. But still, for this application use case, this is an extremely easy. Just the fact that I can, with some certainty, just explain the solution, it's a very simple solution, and I like that it's a simple solution to a fairly simple requirement as well. What we do then is that we use the fact that Elastic has the concept of data tiers to have the basic idea that some data is has a higher temperature than others, because that's the terminology. You have hot, warm, cold, and frozen tiers, and that you can think of that as how much speed do you go. So the hot tier, that is basically where our data is coming in. That's the fast hardware. We're running on Elastic Cloud, Elastic's own cloud hosted solution. And when we run Node, which is hot tier, that basically means besides some hardware spec thing, we get SSDs, and we pay for that, of course. And we need that because storing 200 logs per second actually does require some compute capacity. It doesn't need to, at the time of indexing those data, analyze the data so that we can actually query it afterwards. When we write these audit trail data, we don't really care about, as I mentioned before, that it's not really important that we collect them, but it's fine that if they're a minute delayed or something, that's totally fine. So we utilize the fact that in Elasticsearch you can tweak when Elasticsearch by default will not make things searchable at the time that you write the data to. You will always just write to the protection log, and then it will do internal refreshes that decides when this data will come in the search. And the default value is 1 second. We have increased that to 30 seconds because why bother using more resources than we don't need to keep the data that readily available, so we can save some resources by just. Another thing we also do is that we for our write index, the one that is the current date, to even out load of the cluster running on, we have 2 shards per index. So every index, the barrel underneath in the hot tier is running 2 shards, which is a Lucene index. It's great to know. So that we can actually parallelize, right? So underneath this, we are still running a high volume cluster with multiple nodes. So that means that for the data today, that index, the shards of that index can be spread across those 2 nodes we have, and then both nodes can handle and even though, as I said, 200% is not insane amount, but that still means that we can run 2 fairly small machines. And instead of one bigger machine that needs to handle. Then at some point, which we decide based on a lifecycle policy, we say now this data we don't want to keep it on the hot tier anymore. It's we know that it's not being written to anymore. Let's just have that moved to the warm tier, which is cheaper, basically because on the warm tier, when you use Elasticsearch, it depends on how you host it, of course. You get good old HTTPs, so that's just cheaper, and that saving is passed on to us, like that. So it's slow to search, and that's fine because that fits our use case. We don't need fast search for when the municipality needs to do audit on its employees. They do it like they just pull a report basically from us. That's what they do. They do is for a search, and they say, please give me that result back, and that's fine. That's it. As part of moving it to this one tier, we are putting it through a couple of steps, which is also handled by these lifecycle policies, which Elasticsearch just has out the box, and where we do the most common things. We string to 1 shard per index because we had 2 shards at the time of writing, because that enabled us to parallelize and use compute resources across multiple machines. We don't need to do that anymore. Now it's just going to sit somewhere and be buried once in a while. That's totally fine to merge those 2, because that saves resources also on that, because shards cost memory. We also force merge the index down to 1 shard, 1 second per shard, which is basically just a way to say everything is inside of Lucene within 1 big segment, which is where the search platform, which also optimizes resource usage. And finally, we can mark the index read only. We know we're not ready to anymore, and that also saves some compute resources. Yeah. So this is to this data item here. This is very common. There's no rocket science in this, and I know that this is what you could do with Elasticsearch for 8 years, even more. But also to show that even though Elasticsearch is this platform, you can just log, you can billions of records put together. It's also very good at just doing something like this, which is also something we need to. It's a problem we need to solve as well. by just and this really grew from the fact that we had used Elastic products. So we was having knowledge with Elastic, this was a easy solution for us to see with the experience we have. Finally, a bit about hosting on Elastic Cloud. So that's basically just the instead of going through Azure and running some Elastic servers, we go through Elastic Cloud, which is offered by Elastic, and then they host our machines on Azure for us. And the thing that I would say this is proven to be very valuable to us. We started out doing on-premise hosting, good old servers running at our Danish provider. And I myself installed the first Elastic servers. I also upgraded the Elastic servers, and I heavily buried decommissioned those servers at some point again, because it is quite a work to maintain Elastic cluster with nodes running yourself. Just doing an upgrade, downloading zip files, building script for installing this. There's a bit of work. I really say that using Elastic Cloud, it's really about the flexibility and the opportunities we now have that is more realistic. So for instance, the thing I just showed before, we're using hub tier and wall tier. And I would like to ask Frederik, why isn't he using code tier? I might say that's a very small phrase. Frederik is one of the guys who's running the network. Why are we using code tier?
Why we aren't using?
Why are we using it? Because with code tier, you can get you don't have to run highly available, and then you can remount in case of a machine goes down. You can remount from a snapshot instead of having a column disk. That can save us, I think it's 10–15%. Why are we doing that? We can have a discussion about that tomorrow, and then we can.
We already. The price is exactly the same as you want to, or the exact same amount of data. But the obvious benefit is that obviously there's no failover if you don't have replicas. But in case of, as you said, a crash of some sort, then the restore from the backing end license will be automatic instead of manual.
Exactly, and I think I can do that. As a decision maker, I can live with that. We can save 10–15% by using code instead, because we know it will recover automatically. That's the most important thing, because recovering manually, that's not fun. So this is the kind of decision that is great for us to be able to take without having to go through either a third party or having to say, oh, let me just Freddie, could you make this script? Oh, it's going to take 2 days, or it's not worth it to try. But now it's much more a decision-making process we can have. So I think that really enables us to utilize things that can provide us value. And of course, the fact that it's a managed solution, just the fact that there's an upgrade button. I mean, it's still for me, having done upgrades manually, having built our own deploy system that could upgrade servers via custom scripts, it's still magic just hit the upgrade button, select version, set upgrade, and then just look at the stringer going around until it's say, I'm done, without any downtime. I think that's really valuable. And I'm not aware of any other ways to achieve that. Be cautious. On Azure, there's on the marketplace, you can go and select an Elasticsearch cluster. And then if you provision that, now it has provisioned 5 virtual machines with software running on it that you now maintain. Go have fun. I don't want to be there again. So really have about that. It has also provided us the ability to be more flexible about which assets we have. When we ran Elasticsearch on-premise myself. When I said that we were using Elasticsearch in many teams here in Schultz, it was really based on the fact that we had one big cluster and we had one person that agreed with everyone how they were going to use Elasticsearch, because I wouldn't want to maintain any more than one single cluster, because maintaining 5 clusters, 5 new teams would be, that's my time that I'm not taking away, right? So the 4 use cases I talked about here, those are running as 4 different Elasticsearch clusters, because that gives us the ability to scale individually, to consider the cost of them individually, whereas the previous one, it was just this big bucket of data and nodes stuffed into one big pile. And with all the problems that came with it, just doing an upgrade when everyone was using different versions of beats and stuff like that. So it's definitely a lot easier to manage, but it's also still a complex platform. I mean, it's just the fact that you're trying to put data across six different nodes that can fail over automatically with 10 terabytes of data and 20,000 writes per second. That's still a complex thing. So Elasticsearch is definitely also a complex product and can do a lot of things. But definitely Elasticsearch makes it a whole lot easier. Yeah, and one final thing, comparing to, for instance, Azure Storage Account, which is you can say the opposite in terms of how it runs. Elasticsearch is still compute nodes you buy. So it's still, I know that I have 2 hot nodes, which is running with 32 V cores. And if I don't have enough CPU, I have to consider if I have to go out to a different tier, and that tier, that's a bump that I have to select. I can't scale 5%. I have to scale in brackets. So that's just a thing to consider as well when we run it. Yeah, that's what I have to say about Elasticsearch. I would say that I don't know if it's that the conservancy as such things in our company here. We use SQL Server a lot, and we have a lot of people know a lot about that. We're using Elasticsearch a lot now. We have more people who know about that. And making technical decisions like taking something like Elasticsearch is also really a choice, because we need to make sure that if 3-4 years down the line, there needs to be someone who's able to actually maintain this and not get the crap out of the guy who made it. So that's it. Thanks.
Thanks a lot.
Any questions?
So I've been involved a bit in this as well, and I feel like there's been a lot of changes. So when we started out the cloud solution, there was a lot of stuff it didn't do for us, and now there's more. So it's actually more of a question for you, but maybe also for you. I want to ask you, but do you think the speed will be the same in like the speed of the evolution of the cloud platform, or is it more stable now? And I think maybe the question could be to you as well. Do you feel like it's become more stable in the evolution, or is there a lot of things that need to still evolve even more?
Who are you asking first?
So I mean, from our perspective, since this cloud product will continue for a very long time, but the other big thing that we're bringing out now is serverless, which is tying very nicely to your point about thinking in nodes and CPUs and everything. Is you don't do that anymore. You just think in resources and you get an endpoint, and we'll scale the endpoint, and you don't know and you don't care about what it looks like behind. So I think a lot of the speed will come from that, because probably cloud is a more stable product. It's not like we don't have a very long backlog of things we would like to add, or you and other customers would like to add. So we'll keep adding features as we go along. I think we've very recently added like the next iteration of like having multiple owners of the cloud account itself, not a cluster, but the cloud account. Because before it was all or nothing, and now you could have, for example, I'm making you, or you can only manage one cluster and not all clusters in our account. Or you could have different roles, or you have a billing role, so you see the billing of everything, but you cannot make any changes to the clusters. That was a recent change, I think. Another thing, without promising any timelines, that is, I think, coming relatively soon, is bring your own keys for the on-disk encryption or at rest encryption. So there are a lot of features that are still coming in the roadmap, but I think it's a more complete product than it was before. Also, I would say over the last few years, we built quite a few features that made more sense for cloud, and the years before we had features that didn't make so much sense for cloud. So for example, before Index Lifecycle Management, ILM, there was Elastic Curator. That was this Python standalone thing that you could run to manage your stuff. But if you that's not available on cloud. So if you had to run that yourself against the cloud service, that's kind of like defeats the purpose of the cloud service. ILM is running as part of the Elasticsearch cluster. So it's kind of like built in and fits into the cloud story much better. So I think there is a set of features that we have built in. There's still a very long backlog to add to those, but we are in, of course, a more stable place. And I hope that shows for you as the user in the end product. Or what are you missing? That's often the more interesting question.
I don't know. I think maybe that's a question to you as well. Are we missing stuff still, or are we getting there?
I think I basically agree with everything you said, really. But I think that Elastic has become was it 2019? I think we started running on Elastic Cloud, and I think in those 4 years that have passed, it has gained a lot of maturity. There's a lot of features that has come that has been on, really important, right? And I think that it's clear that making catching other things you did. I would imagine you had on your background this as well. When you mentioned stuff like ownership, for instance, or we say in less cloud, that is still something that is there's a bit of things that like, but I think that there's a good progress. That's the most important thing. That we see that we catching other things that is that we also can see this is something that we think is important.
Or the acquisition that we have done very recently, or I mean, the acquisition is still going through with Obster, which helps to, or it's a tool or a company just to monitor Elasticsearch, basically. That will also then get integrated into Elastic Cloud, because right now the built-in stack monitoring is not as good as I wish it was. And that will give you better monitoring, but it will also give you more tips of how to or what to change, because it might say that, oh, you're over provisioned. Yeah. Because right now, you basically need to figure out that you're over provisioned or under provisioned yourself. Yeah. And there's a lot more tooling that we can build in. And Obster has a product will then move into cloud and give you those tools, because right now it's this shared model of like we provide infrastructure and you have an API or a UI to do stuff, but you still need to do stuff. And with Elastic Cloud, that model will not change fundamentally, but the tooling to make your life easier will change. And then again, with serverless, the model moves, where I always compare it to kind of like, it's like you want to eat a pizza, and either you make the pizza at home, that's kind of like you host it yourself, or maybe you order the pizza by, I don't know if you have Volt or whatever is common here. That's kind of like the cloud model today. And then you could go to the restaurant, and that's kind of like the serverless model, where you don't even need to provide the table and the plates anymore, but everything will be provided for you. It's kind of like this shift of approach. But maybe you enjoy eating at home as well. So maybe you want to stick with cloud, and that's totally your choice. Or maybe you want to prepare the pizza from scratch, that's also a choice. But we want to give you more of these options for whatever makes sense, and whatever the reasons are that you want to go a specific route.
Any other questions?
Yeah. So in cloud, the cloud takes care of redundancy and different scenarios and things like that. for you?
It always makes sure that it takes care of split trace. So for instance, if I want to be high available, I need to have more than one node in the same tier. I can't have one machine. It will always warn you all saying this is data loss in the event that the underlying hardware, VM, whatever it is they're running underneath, if prices go down, you will lose data up to the point that the snapshot has been taken. So then you of course say, oh, I want to run two nodes, and I have replicas, and then I have two machines, and now you have the split rates. And that's when they always put in a tiebreaker if it's needed. So if I provision two machines, they will, without any charge, just put in a tiebreaker. It says so as well. A small machine with 1 gig or something like that, which basically just does say just say
It's a voting only node.
voting system. Yeah, voting.
So in the example you had where you, in the warm scenarios, you still had the redundancy for the.
Yeah, we have that. Yeah, because you have to do that on the warm tier. That's where the thing I mentioned with the codes here, where if you do that instead, you can, if you can live that, you can decide to only have one machine. If that goes down, it will automatically restore from the snapshot of and with some downtime, of course. But if that's what I said. If that's reasonable in those very rare circumstances, having run on Elasticsearch for 4 years, it has happened more than once. But it's definitely once a year or something, twice a year, something like that.
Yeah, there's some moved node of allocator stuff going on these days, and then also like obviously when you upgrade or anything, like if you have replicas, you can actually upgrade in the working hours. We didn't dare to do that before, but it's become so stable now, so we do it and it works fine. I would just say that yeah, just to support Allan, that so we have the customer face data, and that has obviously needs some replicas, some failovers, and the high and then because we try to save money, we have the internal stuff, the logs, and we're kind of okay if the logs would be like crashes or goes down.
Yeah, then we do.
Once
have
twice.
access to that.
Yeah,
I think
and
we
then
have.
we'll restore the manually from the
I
snap.
think we have 12 terabytes of in our logs cluster.
I think actually no, the double of that, 21.22 terabytes.
20 terabytes, and we don't do replicas in that because that's insanely expensive. We don't care if that those if the machine crashes and we live without log 2 hours. That's fine. We can tell people sorry, it's coming up again.
We actually do have replicas for the writing, and then it gets backed up, and then we move into warm. We remove the replicas because I mean we do have the data somewhere.
Yeah.
If it's crashed.
You will need to monitor your elastic clusters or elastic systems.
Yes, we have 4 clusters which run use cases, and we have a 50 cluster which runs on 4 other clusters. But that's the thing that Phil mentioned that
Obster.
there's
Obster is the company.
something you would shine.
Yeah.
But we're using Elasticsearch monitoring to monitor Elasticsearch right now, and we're running on a separate cluster. That's the general recommendation. You can have a cluster monitor set, but in the case of problems, you can't release the monitor because it's we started there, as at some point realized we need to have that.
And what about the data? Where is your data stored? You know where it is? It's out of the country. It's in the cloud.
We select you select the cloud provider in the cloud region. So we have decided to run an application, and we are running in the data center that our rest of our applications run. Not that it's still running side by side, it's still going over the internet because we don't have a direct connection to